Alright guys, welcome to this video. In this video, I'm going to about 5 minutes, because that's all I have, is how to read pedigrees, going over the structure of pedigrees, what they are, and all that fun stuff, okay? So give me 1 second here. Perfect, so what a pedigree charts is, let's see here. Let me go ahead and forward for you guys just to get to the good stuff. I know some of you guys already kind of perused through a pedigree and what it is, but I'm going to go over it right now. So a pedigree, all it is, it's basically a chart that is tracking your family history, and it's really helpful when you track a certain disease or a certain trait. Now let's go over the structure of a pedigree real quick, right? So females are going to be represented as circles. Males are going to be represented as squares. And if the sex is unknown, it's going to be represented as this diamond. Now, if you see a circle or a female with a shaded circle, that means that that is the phenotype of interest. So if you're tracking a disease like hemophilia, if a female has hemophilia, she would have that shaded circle. Same thing for a male. If the male has that trait, then it would be shaded. Same thing if the sex is unknown, that would be shaded as well. Now, if a female is heterozygous, you would only do half of the shading. It's kind of interesting, because you only carry half that trait, right? If the male is heterozygous, only half of it would be shaded as well. If it's deceased, you kind of just do crossed over. If it's a stillbirth or a spontaneous abortion, which you won't see a whole lot of those in the examples that I give you, it'll be represented as this dot. Now, when a male and a female mate or they have sex, we represent that by this straight line across from each other. If there's mating between relatives, or some of you may call this incest, there are two lines, right? So if your sister and your brother mated and they had a baby, they would be represented by two lines, right? The Roman numerals here represent generations. First generation, second generation, right? So in this particular pedigree, you have a male and a female get together, and they have 4 children, 3 of which, 1, 2, 3 are female, and 1 of which is a male, right? Perfect. So let's track this particular pedigree, right? So we have a male and a female. They don't have the trait that we're looking for, right? They mate, and they have 1, 2, 3, 4, 5 kids, right? One of their females, the second one that's born, has this trait. So it has trait, right? Now, look at this male right here. Or I'm sorry, look at this female right here, mated with a male that does not have a trait. They had 3 kids, right? 1 female, 1 male, and another female. That female mated with another male, right? And now let's go back up here. We have this male had mated with a female. They had 1 son, who then mated with a female, had 1, 2, 3, 4, 5 kids. 2 of those kids have that trait. Notice that they're shaded, right? Now, let's go over a couple of things that you'll see over here. This is the first generation, right? Mom and dad are the first generation. And then the second generation is all of this. Third generation is all of this. And then the fourth generation is all of this as well, okay? This is just basically saying that males are represented by squares, females are represented by that. Let's see here. Perfect. Let's go over a couple of these here. Let's see, how much more time do I have left, Mr. Aragon? Let's see, I'm assuming I have more time. All right, perfect. So, in this particular trait, we're tracking sex-linked disorders, or X-linked disorders, right? Colorblindness, right? So, the key right here is if you're orange, you're colorblind, right? If you're yellow, you have normal vision. If you're yellow, you have normal vision, but if you are both, that means you are a carrier, right? So, for this particular trait, you have a male that is normal, right? Mates with a female that is a carrier, has 2 males who are colorblind, right? Mate